everyone, and thank you for coming for my talk. And my name is Paweł, and I work as an iOS developer for 5 years now, still loving it, as you can see from the emoji. And I have a mobile consulting background, so I spent most of those 5 years working mostly for software agencies, software houses. Although right now I'm working as an iOS developer at Allegro, so we're maintaining our own application. So I just switched my background from services to product recently, but it doesn't matter where you work, because those tricks and tips I would like to share today during the presentation apply for the product environment, they apply for the services environment, or even if you're an indie developer and you're just working on your own application, you can still learn something from it and just apply those tricks to your application as well. All right, so what are we going to talk today, right? What are we going to talk about? Well, let's just jump quickly to the subjects I would like to discuss, and these are string-based APIs, interface builder, prototyping, and snapshot testing. I don't want to go into any details of those right now, but as you can see clearly, this is an iOS talk, so if you're just Android developer, maybe not interested, I don't mind if you go to different talk. I mean, if you don't, just stay. This is a purely 100% UIKit and Swift-based presentation. All right, so before we start solving problems, we need to define the problem we want to solve, right? And our problem is the cumbersome UI development, because let's be honest, the current state of UI development on native platforms is not perfect. It's rather far from perfect, and there are a couple of reasons about it. So the first one is that we are using imperative APIs that make the UI development slow. So instead telling the code what we expect from the user interface, we still need to tell how the UI is supposed to be made, which obviously results with more code being written. Also, we are lacking modern tooling like hot reloading, and technologies like React Native or Flutter address those issues by providing declarative APIs that allow us to work faster. And furthermore, they extend their tooling with modern features like mentioned hot reloading, which is kind of absent in the mobile world. And native world, I mean. And also a struggle of constant rebuilds, because of course, to validate changes made to the user interface, you still need to rebuild your own app. And you have to send it to your device, check for changes, which actually takes time and can be a struggle as the size of your code base increases and the build times are higher. And you may think to yourself that, well, Swift UI is here to come. So yeah, we have existing solutions that address those issues. And that's true. However, since Swift UI is compatible with iOS 13 and later, I hardly see many of us using it in production anytime soon. So we still have to deal with UIKit. We still have to deal with the old user interface frameworks, but we can make the development a little bit better. And sometimes, as you know, it's the only option for us, because we cannot write our application in Flutter or React Native in some cases. For example, if you're dealing in a legacy code base and maintaining the app over the years, it's very costly to rewrite the entire application from the scratch. Or if you're working on a specific scenario like complicated use case. Let's take audio processing or video editing app, for example. Some of the APIs in the native framework may not be exposed to the abstraction layer, and therefore making it even harder to write it using the cross-platform solutions. So yeah, some of us are stuck with UIKit, some of us are still stuck with Swift. We have to maintain our apps. We have to assure that we're backwards compatible. So the question for us is, how can we improve the UI development at its current state? And there are many, reasons why I'm doing this talk. I want to showcase you a couple of solutions. The first one is about eliminating string-based APIs from the code base. So yeah, when it comes to string-based APIs, they are like a super common citizens when it comes to interface development on iOS. Because you can find them, for example, in Storyboard references, localizable strings when you're accessing the value of the localized string by its own key, which is also string-based. Reuse identifiers for collection or table view cells, images, colors, fonts, etc. Many other examples. So let's take a look at this example, which is using the UI image named initializer. And as you can see, this is also a string-based API, because if I want to reference the image from my asset catalog, I still need to provide its name via the string value. And what happens if I make a typo? Actually, in this case, well, nothing but happens, because underneath this implementation of UI image named, we have an initializer which returns an optional value. So either I'm gonna get a value or a nil. So unless I force unwrap, I'm safe. Nothing but happens. Maybe I will get the image, maybe not, but anyway, right? But let's take another example. And let's take a look at this API. So right now, I'm accessing a storyboard file via its file name. And from the storyboard file, I want to instantiate a new view controller with a given identifier. And what happens if I make a typo in the file name of the storyboard file? Well, after I run it, my app crashes. So that's not the kind of behavior I would like to see in my apps, right? Swift is just like a strongly typed compiled language. It should be evaluate such things at compile time. I shouldn't worry about it. I mean, let just compiler worry about it. Instead, I'm just like, I have to take care of it, and I'm still getting crashes. So we can address this issue. And to do that, we have to define what's actually wrong, what do we want to address. So what's wrong with string references? Actually, first and foremost, they're typo dependent. So like I said previously, I think that's rather obvious. And since they're typo dependent, they are used to resolve various references, making typos in them leading to some unwanted behaviors. So we've seen it a moment ago. We can either, retrieve no value or maybe crash the entire app. They cannot autocomplete. That's obvious, because strings are in fact a chains of characters, so we don't have this, strong typing. So, well, the IDE cannot predict what are we going to type in the string value. So the risk of making typo is even bigger. And they require declarations in multiple places. So let's take, for example, I mentioned UI table view cell or UI collection view cell. I mean, I have to retrieve my collection view cell via reuse identifier, and when I register the collection view cell in the code base, I still have to provide the same identifier, so I make sure that it's declared the same in two places. I mean, you can just jump through this issue by using constants, but not everyone is using those. So yeah, finally, they guarantee absolutely zero compile time safety. Like I said, everything, the unwanted behavior is happening at the runtime. Crashes are happening at the runtime. Missing assets, missing images are also happening at the runtime. I mean, let the compiler worry about it, not me. So how do we change those kind of APIs where we have, like previously mentioned, UI image or localized strings and storyboards to strongly typed APIs like this? Well, there are a couple of solutions for that, and the first one is SwiftGen. So yeah, probably it's the best idea to use a tool like that, which actually, as you can see on the slide, is a tool to auto-generate Swift code from resources of your projects to make them type safe to use. So we're getting these nicely strongly typed APIs instead of stringly typed APIs. You can find it on GitHub, so go to the repository, just check the documentation, see how can it be integrated to your project. It's really simple to integrate, so you can install it via Homebrew, Cocoapods, or any other tool, and take advantage of this code generation module. SwiftGen runs as a build phase for your project. So every time you change something in your resources, like for example, change the name of the asset, it's gonna check for those changes, auto-generate the types once again before your project even builds, and it's gonna be caught at the compile time. Also, it comes with a tons of predefined templates. So you can use SwiftGen for assets, catalogs, colors, fonts, user interface builder files, strings, etc. It's not even only UI, it's also for core data or plist file. And it can be extended with custom templates. So probably many of you in the room are familiar with a meta programming tool called Sorcery. Sorcery is using actually stencil templates to define the way we want our code to be auto-generated. And you can use stencil as a templating language for SwiftGen as well. So you can take advantage of it and just modify the existing templates or create even new one if you're not satisfied with the way the auto-generated code is actually being made in your project. And like you probably guessed, it just resolves 100% of the issues mentioned previously, because we don't have to worry with the string-based APIs anymore. We have instead nicely generated, predefined, strongly typed enums and structures. So SwiftGen configuration file is being configured using the YAML language. So you can see an example of a simple configuration right here. As you can see, I'm generating strings, localizable strings. Auto-generated code in an output generated that string Swift. So I'm taking my localized strings as an input. I'm providing the template I want to use to generate these resources, and then I'm just like running the SwiftGen script, and it works for me. So the same thing with assets, just provide input, a template, and outputs, and the same with interface builder. So yeah, that's about SwiftGen. And we have mentioned also an interface builder in this talk, so let's switch to that. As you noticed previously, we've talked about it a couple of times, and keep in mind what I would like to share right now with you is that this tool can be either an ally or a foe, depending on how you use it. So when it comes to interface builder, let's take a closer look at how the tool is actually being used, how actually it behaves in our Swift projects, and what it comes to using Interface Builder. So first of all, Interface Builder comes with many good reasons to use that tool. And first of all, creating views without touching of any UIKit code can be obviously a great plus, especially if you're beginners. So because, as you know, Interface Builder allows us to create interface with just a couple of clicks of a mouse, and we're done with simple views. And when it comes to Interface Builder, it is also a great tool for prototyping. And Interface Builder, well, it just allows us to quickly look on our app with various screen resolutions or size classes, so we can have a quick glimpse on how our interface is going to like on many different devices. And it can be used to create entire screen flows thanks to Storyboard segues. So going beyond just creating simple views, we can create entire scenes and screen flows, making it easy to create navigation and transitions with just like a couple clicks of a mouse. And it decreases the amount of written code, which is obviously a win, because, you know, it's more code to generate from Interface Builder and less code to write for ourselves. But Interface Builder has also many disadvantages I would like to showcase for you. And the first one is XML files, because what's bad about Interface Builder is how it approaches its own files. As you know, storyboards or NIPs are in fact XML blobs underneath, and such data structures are rather difficult to code review. And I often caught myself checking only for misplaced constraints, because the code which is generated from Interface Builder can be very difficult to review. So it only keeps getting worse when you're, for example, having multiple scenes in a single storyboard file, or, for example, creating a highly nested structures of a visual representations. And what's even worse, reviewing XML files is nowhere as painful as resolving merge conflicts in those. There are obviously ways to greatly decrease amount of such conflicts, and I'm going to showcase some of those a little bit later, but it's worth keeping in mind when working simultaneously on a single storyboard file. And the connections between interface builder and code, known as IB outlets, can be dangerous too. Because outlets are by default declared in the code as implicitly unwrapped optionals, while their names are stringly typed on the side of XML file. And customization of the views created in interface builder is also limited. So it's not that we can do everything in interface builder. We can extend the base functionality, but it's not enough. For example, if we want to create a more complex customization or animations, we still need to do that in the code. And finally, interface builder is simply not your friend when it comes to dependency injection, because if you're using segues and would like to provide a dynamic screen flow inside your app, the storyboard segues can be actually cumbersome and unpractical, because the segues are also defined by string-driven APIs, and transitions between those views are very difficult to manage when it comes to injecting additional data for the target scene. So it's, in fact, a little bit more difficult than it should be. So as you can see, there are many good reasons to use Interface Builder, or many great reasons not to. And it's not my intention to persuade you in any direction. If you like using or not like using Interface Builder, that's fine. However, I'd like to state that with my current team and previous teams, we decided not to use Interface Builder in any of our production apps. And with that, there's just like one option left, which is writing your layout directly from the code, right? So yeah, the biggest difference between those techniques, I mean interface builder and code approach, lies in how we approach auto layout. And fortunately, writing auto layout from code is way less difficult than it sounds. So let's take this simple view consisting of 3 elements. There's a header extension, it's a light gray area, there is a table view in the middle, and there is a toolbar on the bottom. Can you guess how many constraints do I need to declare to create a simple view? Well, first of all, let's start with the top area for the header extension. So we're just gonna constrain it to the header. And then we have to constrain the leading edges and trailing edges, and then set the height of 120 points, because that's the requirement from our designer. And then I'm going to constrain the toolbars. I'm gonna constrain the bottom of the toolbar to the bottom of the safe area. Then I'm gonna constrain the leading edges. Then I'm gonna constrain the trailing edges, so that's 7 already. And then I'm gonna switch to the table view to place it between the elements. So right now I'm gonna align the bottom of the table view to the top of the toolbar, and then I'm gonna just align the top of the table view to the bottom of the header extension, and then I'm gonna finish with leading edges and trailing edges, so that's 11 constraints in total for such view. It may be simpler, you can use a UI stack view for that, but I just took an example of fairly simple view with many constraints to make it happen. And yeah, so right now with this knowledge, let's write down those 11 constraints in code. And when it comes to writing user interface in code, there are like 3 main approaches you can take to do that. The first one is NS Layout Constraints API, which is declaring direct relationships between 2 user interface objects that must be satisfied by the auto layout solver. And to show you an example of those 11 constraints created with this API, just take a look at this code. I mean, probably the guys in the last rows cannot see anything on the slide because it's so verbose. Each constraint initializer takes 8 arguments to create a single relationship between those views. Therefore, with more complex layout for our code bases, it just tends up to swell up as number of constraints increases. But there are different approaches. And the other approach is the layout anchors API introduced with iOS 9. It brought us many advantages of the previous one, like brought us many advantages over the previous one, like additional type checking or easier and cleaner to read API. So let's take a look at another example of how your interface can be declared using layout anchors. And it looks like this. So I think you can agree that this code looks more fluent and developer friendly. And I can see myself using such API on a daily basis. It doesn't take as much typing as the previous one. The relationships between views are easier to understand at a glance. However, it's not the only approach worth considering. And the approach I am using towards creating constraints in my apps is auto layout DSLs, which means domain-specific language. So those domain-specific language are tools that reduce the verbosity of constraints even further by simplifying repetitive tasks. And my favorite example of such tool is cartography. Cartography is actually a framework you can just import to your project, and it's just here you can see an example of coordinate systems created with cartography. So cartography is actually a fantastic example how you can take advantage of various Swift features and make the API even simpler and declarative. For example, you can see an overloaded operators, which are being used for assignments between two views. You can use also overloaded operators for constraint priorities and etc., but it's more advanced layout. I just wanted to showcase a simple example. Therefore, repetitive tasks are limited and relationships between views can be understood at a glance with less amount of code written. So yeah, that's the entire view, 11 constraints made like that. And if you're still not convinced, I mean, that's fine. Like I said, I'm not here to persuade you. However, I highly recommend giving Programmatic auto layout a chance. Combined with the custom view classes, it solves like 100% of the issues coming from using interface builder in team environment. But if you're still using interface builder, that's fine. Keep using it, just like a couple of good practices you can take to your project. So for example, keeping each scene and separate file greatly increases team efficiency when working with storyboards, because separated storyboard files open faster and decrease the possibility of merge conflicts, which is a huge win. Also, dependency injection, as we know, using the segues is quite difficult. So consider dropping segues from your interface builder, but if you're still using them and want to keep the scenes separated, you can use storyboard references. The reference just like a different storyboard files and view controllers in them. And you can still use SwiftGen, as mentioned previously, because it works with interface builder. So if you're just like cooperating between interface builder files and code, you can access these strongly typed generated resources. And you can finally, when working with outlets, consider replacing implicitly unwrapped optionals with standard ones. So just like change the exclamation mark to a question mark. This way you can avoid unexpected crashes. However, the entire regression check of your outlet references still needs to be made, because if something goes wrong, you're just not gonna notice it probably. So you need to do the regression testing. And when we are dropping interface builder from our code base, we are obviously getting rid of a great prototyping tool. So how do we build up on that? How do we actually use different tools for prototyping? And the question is, how do we avoid constant reruns of our apps to check how the layout is going to look like? And there are a couple of solutions for that as well. And you're probably familiar with the first one, which is Xcode Playgrounds. And when it comes to Xcode Playgrounds, as it turns out, it's a really good tool that gives us nice possibilities of UI prototyping. We can use framework dependencies in Playgrounds, either internal frameworks if you have like a modular architecture, or external ones if you're, for example, using Cocapods or Carthage for the dependency management, as long as they're added to our project. So just remember to add the Playgrounds to the existing projects, and then you can take advantage of the frameworks inside the Playgrounds. Because Playgrounds run in a sandbox environment, so you won't be able to access your code files directly from your application target. However, you can just like wrap these files and make a separate framework out of it and then expose it to the playground. Or you can move it to source and resources files, source for code and resources for assets, etc. inside the playground, so then you can access the code. And yeah, so keep in mind that Sandboxed is just like runs separately from your app, and maybe you won't be able to access all of the code, but there are possibilities to overcome that. And what's worth noting as well, Playgrounds stability greatly increases when they are executed manually. So if you're, for example, doing the visuals in Xcode Playgrounds and have issues with playground stability, for example, the internal process crashes all the time, just like consider doing the manual execution over the automatic execution, because the stability increases then. So let's take a quick look at demo on how Playgrounds can be used within an app. So right now you can see that there's some code declared using cartography, and I'm gonna do a new add a new playground to the project. I'm gonna use the single view template, and what's very important, I'm gonna add it to the project structure. And after it's done, I can just go to the playground, add my code for UI declaration, overwrite my load view method to use that code I added above. And since it's using cartography, I need to import the cartography to the playground. But since it's added to the project, it has access to the frameworks. And right now, I have a live preview of the view. So if my build times in the projects are long, I can take advantage of this approach and just like a prototype faster without the constant reruns of the apps. As you can see, the color of the toolbar was changed, and the change was executed almost immediately. There's also another approach over Xcode Playgrounds, which is Xcode Previews, and Xcode Previews are available in Xcode 11 and macOS Catalina. So if you're running Xcode 11 on macOS Mojave, you won't have access to Xcode Previews, although after you upgrade to Catalina, you will have. And yeah, so Xcode previews are Swift UI thing, and but it can be used with UIKit code as well, because as we know, Swift UI has interoperability with UIKit, so you can expose existing UIKit views to Swift UI framework, and this can be represented using the UI view representable protocol, which exposes the UIKit objects to Swift UI framework. And since it has to be also exposed to the Xcode Previews, the preview provider protocol implementation is also required, as this protocol is responsible for exposing your layouts to the Xcode Previews engine. So finally, since Xcode Previews are tightly coupled to Swift UI, you still need to bump your deployment target to iOS 13 to make the code compile. But luckily, since deployment target is just a build setting, you can change it depending on the environment. So you can just bump it up for your debug configuration and set the previous deployment target for release. And that's an example of the UIKit code base used together with Swift Playgrounds, Xcode Previews. So if we can import Swift UI and we're running the debug environment, we're just gonna import Swift UI. We have deployment target set to iOS 13, but only for debug. And then we're gonna fill the UI view representable protocol, and we're gonna create a structure which conforms to the preview provider. Of course, I need to provide the implementation for the protocol, so I'm gonna do that. So I'm gonna just create an instance of my view and then expose it. And after I'm back to the project, you can see that I have access to Xcode Previews using UIKit codebase. So right now I have very similar possibilities as when it comes to Xcode Playgrounds. So when I change my bar tint color, I can still see the changes. So I'm changing it to red right now, and yeah. So yeah, so great interoperability between UIKit and Swift UI, making it possible. And yeah, you can learn more about it on Antoine van der Lee's blog post about it. That's the way I learned about this feature. It's really great. So go to his blog. I mean, it's a really nice source of great Swift articles. So you can use it daily. And yeah. And the last thing I wanted to talk about with you, because if we have our code written, if we have our code base, we need to write tests as well. Or maybe even write the test first. But when it comes to snapshot testing, we need to have our views declared. So yeah, so we're ready to just like publish our app. We need to just add the snapshot tests and let's move on. Snapshot testing is a great view for testing UI view controllers. So, and there are a couple of approaches when it comes to actually testing UI view controllers. What I like doing when it comes to testing those is testing behaviors. So I usually do not test my layouts directly in code because I don't see many value added in doing that. I just don't see myself asserting against, for example, frame sizes calculated by the auto layout engine, and then if my UI changes, I need to change the tests as well, and it's like a very cumbersome process. So instead of that, I can just snapshot those and take advantage of something which is doing that work for me and just focus on testing the behavior. So for example, what happens if I click on a button or if the navigation between views is behaving correctly? That's the thing I can unit test. Although when it comes to actually the plain layout themselves, I just like I leave it to the snapshot testing. So I just want to make it clear, write your tests, don't skip testing, just write meaningful tests, and when it comes to testing layout, I think that's a very good approach. So snapshot testing looks like this. Here you can see an example of the snapshot test where a view controller instance is being validated against various strategies. We can see a strategy of image and recursive description. I will tell you more about it in a while. Tested against same view controller, which is my subject counter test, and then I'm gonna test it on different devices like iPhone 8 Plus, iPhone 8, or iPhone 10 on different orientations like portrait and landscape. So yeah, there are many possibilities to make the tests also device agnostic. So using one simulator, and it was run on an iPhone 11 simulator, which is completely different from all of these devices. You can generate the snapshots from various devices. So no matter on which device you test, you can test against various devices during that using that declarations. And the library I'm using for that is Point Freeze Swift Snapshot Testing. So you can find it on GitHub. You probably are familiar with the Point Free content about functional programming, a great reasons about it. And actually the authors of the website and of the courses are created also this nice snapshotting library for iOS. And here's a demo, a quick demo of the snapshot tests. I'm gonna run it right now. And as you can see, there is an empty test case where I'm just gonna add my subject under testing, in this case, my view controller. And I'm gonna just write the implementation of setup teardown methods. So I'm just gonna set up my references and then I'm gonna import snapshot testing and write a simple example of a snapshot, matching my subject under test as image using the image strategy on iPhone SE, or maybe recursive description on iPhone SE as well. I'm gonna run those tests. It's gonna fail because I don't have any snapshot references yet, although it's gonna generate the snapshot references on a first use. So I'm gonna go to the directory where the references are kept. As you can see, I have the image, I have the recursive description of the view controller, and after I rerun my tests, they're gonna pass. So obviously it's right now matching the references because the references are existing. And if I go and change something in my code, so if, for example, I'm changing the bar tint color from gray to blue and rerun my test is gonna fail because it's not matching the reference. So yeah, really easy to use tool, really cool one if you want to just like plainly test your views against different devices, different resolutions. Add it to your project, import to the test case and start writing tests, as simple as that. It's device agnostic, like mentioned previously. So using the various configurations, you can just like run from a single simulator tests and references for various devices. Lots of predefined snapshot strategies. I show you two strategies for the UI view controller. The first one was image, so it was the actually image file reference. The second was the recursive description. The recursive description takes all of my subviews and just like writing a nested text structure describing how my views are laid out, what's the frame size, etc., etc. And it's just like if I'm obviously using a different device, then probably my frame size for a subview is gonna change according to the device resolution. So using various devices, you will have different results, which is great. And you can test against your views, view controllers, CA layers, but it goes far beyond visual testing. So you can use it for URL request or encodable types or any type of Swift type. And by any, I mean any, the type that is actually compliant with all of the Swift types, because it's using also a dump method from the Swift standard library underneath to create the snapshots as well. And to learn more about it, you can go to point3.co, as mentioned, and watch the episode 41. Episode 41 is free for everyone, so I highly recommend checking that, even if you don't have the subscription, because it's this episode about snapshot testing, where the guys actually are going through the library and showing how to use it in practice. And that's about it. That's pretty much concludes my talk. So there are resources that I decided to use for this presentation. The first one is SwiftGen, so that's static type generator for UIKit, where you can just get rid of these string-based APIs. Cartographia, declarative auto-layout ASL. The blog post from Antoine, like I said previously, really good stuff. So go and check it out if you want to use Xcode Previews. And then also Swift snapshot testing library on GitHub. The tour of snapshot testing, episode 41 of Point 3. Go check it out if you're interested about the library. Not much of code to write, and it's a great advantage when it comes to testing your layouts, because you can check against regression. You can see the diff in your code review, so you can see if something changed in your snapshot and actually make notice if it's like a wanted or unwanted change, or you can just send the generated snapshot to your designer to check for the pixel perfect interface. And also I'm using the John Sanders Xcode theme for the images. So yeah, that's about it. That was my talk. So thank you very much for coming and listening. That's my Twitter handle, Paweł Urbanowicz. So if you like the talk, if you like the content, if you have any questions, just go follow me on Twitter. My DMs are open. If you didn't like it, go and follow me on Twitter, because I don't have many followers. So yeah, but yeah, that's about it. So thank you very much.